too, Hunter, so onward and forward. All right, go ahead and erase your boards. Does anyone want a wet towel to wipe your hands? I know they kind of feel gicky because I live in chalk all day, so I know. All right, you can wash your table or your hands or both. These little buckets come in handy. I don't know what they're for, but they work. All right. All right, Hunter, we're cleaning up our tables from some chalk drawings we made on them. So, I have a dramatic pause for you. All right, open to your notes for what day notes did I last give you? Day 4 or 5, I forget.
Day 4.
Day 4? Okay.
Alex.
Day 4 it is. All right. Looking at day 4, if you don't have this emphasized, yeah, I should have brought some dry ones too. Take out your day 4 notes, day 4, and we had a graph that we were working on that day 4 notes. And the graph matched the one that I tried to draw on the board. I'm not sure how clear we were about that, but if you would, watch this discussion. If it's not clear on your notes, you want to add that. What I'm asking about is good old velocity. Alex, can you remind us what two things are divided to get velocity?
It's x over time.
Right, and we call that, it's not just any old
It's
x.
not just x.
What do we call that change in x? Do you remember the name that we give it?
It is the measurement
Yeah, it's a measurement of what?
of position.
Right, and another word for that is displacement. So position is good, or displacement. And that's even, a lot of times it'll say change of x, I'll read it change of x, but it really means displacement. Displacement divided by change in time, and we were making a big hoopla about instantaneous velocity. For it to be a true instantaneous velocity, what's going to happen to change in time? And Emily Martin, what has to happen for instantaneous velocity or change in time?
It has to be like kind of specific,
Right, so how long will it be then? At a specific point in time, how long will that change in time be? Yeah, an instant, which is infinitesimally small. Were you going to say something else?
So when you're saying it's like infinitely small, like
Right.
it's like 0 or no?
Yeah, it's like zero.
Like 0.
Right,
It's
so
not
that's
0.
why what happens in lab, can we take our board, which we had, and create an interval small enough where we can time the beginning and the end of it and create an instant? It's not going to work. So therefore, we have to find our velocities somewhere else. And we did that yesterday by a graph. So the mathematicians came and gave us a graph, and we were able to create slopes at any point, just like we were practicing on your table, and find the velocity. The velocity on a displacement versus time graph is the slope of a displacement versus time graph is velocity. So we're going to stay there just for a few minutes before we go to the next topic by doing another example. Do you have this on day 4, this graph?
Mm-hmm.
You do. On the back, or
Yep.
where is it?
On the back.
Okay. All right, so the copier was doing, oh, is it the back or another sheet?
It's the back of another sheet.
Oh, wow, you got the copier to work. Awesome. All right. So we're going to work on that one, and here's the first question. So from our warm-up and just our discussion yesterday, can you look at that graph and put a dot on it, and first of all, write the words down, write the question down, because you are creating a study guide on these pages. And the question is, where is the speed the greatest? So let me get rid of this. And the question is, where is the speed the greatest? Did you restart the timer, Zach? Okay. Hunter, this is on the back of the day 4 handout. I think you got through your mom, so you'll find it. This is the shape of it. It's displacement. I think it might say position versus time, so that's interchangeable. Where is the speed the greatest? Put a dot where you think you can find the speed that is the greatest on yours. All right. From mine's not going to be exactly correct, but I tried to trace the shape pretty well. And what I'm looking for, according to my slope map, remember those high slopes were like this and like this? I don't care if it's positive or negative. Where would I draw a dot and the slope was very great? I wouldn't want to be skiing on this part of the graph. Where would that be? Brian?
Where the slope is the greatest?
Yes. Can you give me like a number for time and then I'll know what you mean?
Well, negatively, around 10
Right,
seconds,
exactly.
that's the greatest slope, but positively when it's
Yeah,
technically
positive
going
is fine.
fastest,
It doesn't matter that it's negative. When we're looking
it's
for
just-
slope.
It's in the 1 second range.
All right. So we're right around here though is where the slope, somewhere around 10 and 11 seconds, your dot should be. Was it? Create a slope, tangent line at that slope, at that point, and tell me, is there any other point on here would have a slope line this steep? I don't think so. So I think you pegged it there, Brian. So let me see your little dot and your little slope line. So your dot's going to be on this steep part. Remember, you're the skier, so you want to look for the slopiest spot, the steepest spot. Yes?
So you want it in the middle of the slope, right?
What?
You
The
want
dot?
in the
It
middle?
doesn't really matter, but I think that's a good
So
rule of
at
thumb.
the point of the slope that's the most steep.
Yeah, it doesn't, I think anywhere along here is about the same,
Okay.
don't you? It
But
looks
you
pretty
wouldn't
close.
like put it on the top of anything.
Right, the
Okay,
top
okay.
is a little less steep.
Got you, okay.
So I'd say somewhere between here and here, it looks pretty equivalent as
Okay.
far as slope goes to my eye. So I won't be real picky in that respect. All right, now that we have that question answered, so in words, it's how many seconds? It looks like about 10 and a half, somewhere between 10 and 11 seconds is the answer in words. All right, the next question for that is, how many times does it change directions?
Yeah.
How many, and write this out again, you're creating study sheets. How many direction changes does the object go through? So look at that, and then we'll review what the answer is. Alex, what were you going to
I
say?
think I have the answer.
What do you think?
Isn't it 2?
2? Okay. Anyone have another answer? Or we all agree? Brandon?
Could it possibly be 3 just because it, wait.
Could it be for 3?
Wait. No, wait. It just changes like every time it goes in a different direction, right?
Because every time it does what?
Goes in a different direction.
Yes.
So wouldn't it technically be like 1, then 2, then 3, 4, 5?
Maybe. So we have 2, 3, and 5. All right. Let's do a little finger trace of what's going on. Emily, you got to help me again. You know how we did yesterday. All right, everyone, put your pen in the air. And I'm kind of going to look at your pens this time. I couldn't see them. So, from this graph, I can't tell from the board, so you're going to have to look at yours. I'm going to look at Alex's. All right, so at 0, we're going to pick a spot in the air and call it 0. Now, at 1 second, Emily, where is it?
At like 3.
All right, so at 1 second, you're gonna move straight across to position 3 from 0. Let's do it again. Back at 0. 1 second, you're over to 3. Emily, what happens, say it up to 3 seconds?
3 seconds, you're at 5.
All right, so we're moving more to the right. So this is just a number line, remember? All right, what happens right there at 4 seconds, Emily?
It's still at 5.
All right, so it stays, it hovers. What about 6 seconds?
It starts to go down.
All right,
It's
we're
at
coming
3.
back. Do you see now we're going back because
So it'll
we,
be 1 change.
yeah, so there's 1 so far. So then let's jump over to 7 seconds, Emily.
That is at 2.
2, so we were at, I forget, so that's more to the left. We go back to 2. All right, now what about at 9?
0.
0, we're back where we started, in the air. Brian, I need you to be in the air too. You're at 0, 0, 9 seconds. Now, we are going up to 10, so what happens then, Emily?
10 is negative 1.
All right, so what's that mean, do you think? If we're
Going to the
sit-
left, just keep going.
Yes,
Stay
right,
in the
so we
same
went
direction.
to the right, we came back to 0. We're gonna go past where we started from on the other side of 0, and we're gonna go to negative 1. No big deal. So far, how many direction changes?
1.
So, okay, so we are at 9 seconds. What happens between 9 and 10, Emily?
It goes to negative
9 and 10. It does? Yeah, I guess you're right. So
10
it
is
was,
negative 1.
all right, it's
Then
negative 1.
11.
All right, to 11 seconds.
11 is negative 10.
All right, so it keeps going way over to the left now. So we're at negative 10 somewhere over here. And then 12,
Is negative 12.
it's at negative 12. We were at, it stays the same. All right, then what happens?
It goes back up to negative 8.
So it turns. So
There's
so how many were there?
2.
All right, and now instead of doing a finger thing in the air, a finger trace in the air, what could we do graphically, just looking at it? What could you look at and get the 2 very quickly? Any ideas, Brian?
When it becomes positive to negative, negative.
It's not exactly positive to negative, but
Making
what?
When it slopes.
The slope goes from positive to negative. Okay, an easier way to say that?
I was gonna say, like, when you look across at a value and you see it hit still hit in 2 places.
All right, that's another good point. But is there a simpler way to say it, Zach? What am I looking for with my eye pretty quickly? Instead of evaluating, oh, slopes this way, that way, the finger goes back and forth. What you're looking for is,
It just goes above or below 0.
no, 0 didn't really have anything to do with it, because when we came here, it was going this way and then going that way. But from here, it started going left, and when it hit here, it continued to go left. It just went past where we
Like, if it
started.
changes from like negative to positive,
What?
the number.
The slope, you mean?
Yeah.
No, okay, but how can you say that simple? What I'm trying to get you to say is true. Everything you said about slope changing is true. Any ideas, Emily Martin? Right, when it's peaks and valleys. So you're looking for a mountaintop. Right here is a change, and here's a dip. This wasn't really a dip because it stayed constant. And so down here was a dip, a valley. So you're looking for mountaintops and valleys for direction changes. There were only 2. So make a note of that. Say there were 2 changes. Mark them on the graph with a C and say where the graph, I guess we could say where the graph peaks and valleys. Is that clear what I'm saying? Peaks and valleys. So those are the direction changes. All right,
We have to stop.
what other question? I gotta stop?